Hi, welcome to the first lesson of the IB Physics syllabus at Edu Solutions Institute. We will be going through the IB syllabus primarily for this new syllabus period for exam students 2025 onwards. So the first part of this syllabus is to look at kinematics. Now, kinematics is deal with the motion of objects. Now, motion of objects, we have different terms that we will encounter, as well as we're going to look at different equations that we will have to use. Now, the term speed. Now, when we say the speed of an object, what we're referring to is how much distance an object covers in a specific unit time. That unit time is normally 1 second. So, moving at 25 meters per second speed means that the object covers on average 25 meters in 1 second. Right? So that's the reason why for GPS, it gives you an estimated time based on your distance and the speed limit for those specific routes that you're using. So it uses that to calculate how much time it will take to reach your destination. Now, velocity. Velocity is speed, but specifically in a given direction. Right? So if you're going in a specific direction, then specifying direction, we normally use a positive number or a negative number. So if you see a negative speed, what that means, the negative is giving you the direction that the object is going. Displacement. Displacement is also a vector quantity which regards distance. But more specifically, it compares the starting point to the end point. Right? So if I started here, I moved around, and then I end up here, my displacement is from the starting point to where I ended. What's the distance between those 2 points? So it disregards going around all those different routes, but it only focuses on start and end. So where I start to where I end, I put a straight line, and that distance gives me displacement. Now, distance would be, it has to counter every single place I went, add up those specific locations to give me my total distance. Right? So that's the difference between distance and displacement. Then acceleration has to do with how fast is velocity changing. So if a car is moving 25 meters per second, and then it changes to 30 meters per second, then the car accelerated, meaning it changed speed, changed velocity. It also is true if it was 25 and then it slowed down to 20. It is a form of acceleration. The correct term we use is deceleration. And deceleration is represented by a negative number. Right? Acceleration is represented by positive numbers. So those are the terms that we use in kinematics. Now, this graph shows us distance against time, or displacement against time, where the blue line tells us that this object is covering the same distance in the same amount of time. Meaning, if we check the time every second, then the car or the object is moving the same addition of those distance. So let's take, for example, if we look this point, 1 second, 2 seconds, 3 seconds. So if at 1 second, the object covered 4 meters, then at 2 seconds, we expect the object to cover 8 meters. And then at 3 seconds, we expect the object to cover another 4 plus that, so it's 8. So it's 12, sorry. Right? So this straight line gives us an idea that the object, every unit time, is covering the same distance between those times. Right? Now, this red curve now is different. What it tells us is the object is moving, but it's not moving at a constant speed or velocity. This blue line represents constant speed or velocity. This red line means the object is changing speed and velocity at different intervals. So in cases like these, the examiner can use the term instantaneous velocity or instantaneous speed. And what does that mean? It means we know that the object is changing speed. We want to know what's the speed at a given point. So what's the speed at 2 seconds, right? And that's where, because it's a curve, to find that speed, we will have to do a tangent at that point. So we draw a tangent specifically at 2 seconds on the graph, and then we find the gradient of that tangent, right? And if we compare it to a point that's right here, draw a tangent there, find the gradient, it shows that this gradient is smaller than this one. So the object at this 2 seconds here had a smaller speed than when the object was here, right? And those points represent term called instantaneous velocity or speed. Now, these equations are used to help us to understand kinematics way better, right? So these equations represent objects that are changing speed, meaning they are accelerating, right? Now, the first thing to note is, what do these symbols mean? The V specifically means final velocity or speed. The U represents initial, where we're starting off with. Right? The A represents the acceleration, which is also denoted by deceleration as well. The T represents time. The S, not speed, but the S represents displacement and sometimes can be referred to as distance. The units for these are meters per second for both initial and final velocity. For acceleration or deceleration is meters per second squared. For time is the second. And for displacement is in meters. Right? So these are the formulas we use. Reason, how do we know which formula to use? Depends on what the question gives us and what we're finding. So for one, the equation has to have what we're given, and it also has to have the unknown which we need to find. All right, so we're going to do one question that utilizes at least one or two of these equations. All right, so let's look at this example here. So it says a cyclist slows uniformly from a speed of 7.5 meters per second to a speed of 2.5 meters per second in a given time of 5 seconds. Calculate the acceleration and also the distance moved. Now, the first thing that I normally like to do is to highlight what we're given from the question. Alright, so let's do that here, in this box right here. In terms of the symbols, we're going to highlight what each of these values mean. So the first 7.5 is it slows down from. So from means it's starting with that initial U, 7.5 meters per second. Then it went to this, meaning it is a final 2.5 meters per second. And it did that in a time of 5.0 seconds. Right? So the first thing here is we're going to find the acceleration, which is A. So looking at these U, V, T, and we need A, we can look at the formulas. This has V, U, T, and we need A. So therefore we can use this formula here to answer question 1. So it's V minus U plus AT. We substitute the value of V equals U 7.5 plus A multiplied by 5.0. Right? First thing is to take this over. So it becomes a negative. So it's 2.5 minus 7.5 equals 5 times A, which is 5.0A. Minus this, we get 5.0 equals 5.0A. Divide both sides by 5.0. And hence it gives us that the acceleration here, well, it's negative here because it's is negative 1 unit meters per second squared. So this cyclist was decelerating because it's a negative value at 1 meters per second squared. We know it's decelerating as well because it was at a higher speed and it came to a lower speed. And then finally, what's the distance traveled? So we now have these three, plus we can add our acceleration, negative 1 meters per second squared. Now we need to know the distance, which is s. Alright, now here we see we can use any of these three because we have everything here now. Alright, so for ease, we're going to use the last one here. So we're going to use that s is equal to half u plus v times t. So it is a half u, which is 7.5, plus v 2.5 times t, which is 5.0. So it's a half of, this would be 10.0 times 5.0. So half of 10 is 5. 5 times 5 is 25. And the unit is meters. Right? So we see here that once we identify what we're given from the question, it's just to match now with the formula to see which formula is appropriate to use under a different situation. So this is our first lesson for kinematics. Hope you enjoyed, and see you next week where we will continue with the syllabus and ensure that you are well prepared for your 2025 examination and onward. Thank you.